we've been looking at this idea of functions. And we know that functions are a part of a bigger family of things called relations. What were relations again? Just a graph? Any kind of graph? Any relationship between x and y variables we call a relation. Right? It doesn't matter what it looks like visually. As long as there's some equation and there's some graph which describes it, that's a relation. One of the other ways that we can think about it is a mapping of x to y values. Because I said that the x values you can think about as your input, that's what you're putting in. The y values are what's coming out. I'm going to show you not only are there functions, but there's actually different types of relations, and we give them names too, and we describe them by how they're mapped. Let me give you an example. Y equals to x plus 1. Right? We've seen this many times before. We know this is a straight line. Happened again. Y equals to x plus 1. Right? So it looks like this. If I drew a table of values, looking at their x and y values, right? Let's say we took these values here. What would be my y values? Yep, so we can let's just put it in, right? You can see whatever my x value is, I just add 1 to get the y value, right? Yeah, 1, 0, oh no, that should be a minus 1. So that is 0, 1, 2, 3, okay. That's our equation, that's our graph, and that's our table of values. There's another way we can think about it. And this idea of mapping is like saying, okay, let's take our x values and let's see where they match up with our y values. And these are our relations, right? So if I take the x's, this pen's kind of dying, and I draw these kind of circles, right? I'm saying, okay, when x is minus 2, minus 1, 0, 1, and 2, where do these get mapped to on my y values? Well, what are the y values? They are... Right, okay. If I was to take these values and I was to literally take an arrow and say, okay, this minus 2, what does it match up with my y values? It matches up with, what does it match up with? Minus 1, okay. And minus 1 goes up to... 0 goes to 1, 1 goes to 2, 2 goes to 3, right? This is a special type of mapping, and the name is called one-to-one. Does anyone have a guess why it's called that?
Because you've gone from one thing to one thing.
And they're quite intuitive names. For every x value you have, it matches up exactly with one y value. Okay? And this is what we call a one-to-one relation. For every x value, it matches up with one y value. Okay? Can you get this down for me? So obviously, if there are one-to-one types of relations, there must be other types as well, right? And there are. Have a think about how they manifest, right? If I have this equation here, y equals x squared, I know that looks like my standard parabola, right? There's my standard parabola there. And I say, all right, let's go ahead and fill in this table. When I put in an x value of -2, what happens to my y value? I'll get -2 all squared, which is 4. Same thing with these ones. We get -1 all squared, which is 1, 0, and then hang on. We start to see the same values again. So now I want to think, okay, when I'm drawing my mapping, right, this mapping is saying, okay, what's my input? What are the x values that are going in? And the y values are what's coming out, right? Let's have a look at how that changes now. Let's have a look at these x and y values. What are my x values? Well, they're still the same. And it's important to note that, like, I mean, these x values can go on forever, right? But I can only fit so many on here. It's just to get an idea of what's going on. I don't have to do all the possible x values to identify the type of mapping that's actually going on here. What do you notice about the y values? Yeah. There's duplicates here. So in this one, in our one-to-one function, for every x value, it matched up with its own y value, and there's no other arrows that are crossing or going to it. But for this one, have a think. We actually only have 3 different values here. I've got 0, 1, and 4. And in fact, right, hang on, -2, that matches up with 4. 1 matches up with, hang on, I keep doing that, it should be -1. -1 matches up with 1, 0 matches up with 0, but then what happens after that? Well, hang on, 1 also goes to 1, and 2 also goes to 4, okay. So what's different between these two? It up. So this is 1 to 1 because I guess you can think about it as like one arrow matching up with one thing here. But this one, you've got multiple pointing to the same one.
2 to 1.
Yeah, 2 to 1, or we just call it, like in this case it's 2 to 1, but it can be more than that. In this case we're going to call it many to 1. I just mixed that up, yeah. So it's many to 1 there. And I think the emphasis is on like, okay, yeah, how are these arrows, right? I've got multiple pointing to the same one, right? If that happens, that's a many to 1. Let's look at what happens in this case, right? I know that this visually is actually going to look like a sideways parabola. How do I know that? Well, first of all, if you try and put -1 into it, you're essentially trying to solve this, which doesn't have any solutions in the real space, so we can't do that, right? What about if x is equal to 0? What would that be equal to? 0. Yeah, this is going to be 0 as well. And you notice that, hang on, if I have y squared is equal to 1, what actually happens? What are your answers for y? Yeah, you actually have 2 solutions. And if it's equal to 4, you're going to have 2 solutions again. You're going to have... Okay, so visually what this looks like, if you plot it out, it actually looks kind of like this, which is going to be like a sideways parabola. And again, right, we have this graphical approach, we have this table of values, we have an equation, but we can also think about the mapping, right? You've got your x values and you've got your y values. Your x values now, we've only got 3 of them here, 0, 1, and 4. What about the y values though? Yeah, we've got quite a lot more now. We've got -2, -1, 0, +1, and 2.
Oh, that one's 1 to many.
Okay, so let's see what happens. So 0 goes to 0.
I see what's going on here.
What does 1 go to on your x's? 1 goes to 2 values. It goes to -1 and +1. And
That goes to -2.
yeah, 4 goes to -2 and +2. So again, the names are trying to be quite intuitive here. It's saying, okay, I have 1 x value, yeah, and it's going to many y values, so we call it 1 to many. There we go. 1 to many. Yeah. Why is it a thing?
Yeah, I don't really like this circle thing.
Ah, speaking of which, hang on, there's actually one more type. If we've got 1 to 1, many to 1, 1 to many, what have we kind of left out?
Many to many.
Many to many. Okay, so, I mean, many to many, what would that mean? Try and think about the mapping perspective, right? It'd mean I'd have, like, many of these mapping to many of these. Okay, and an example of that is a circle. Let's see how that actually works. X squared plus y squared equals to 2 is going to be my equation. So there's my circle. The table of values I want you to fill out are a bit different though. It's going to look like this. So, like, for example, right, if you put in your x value, negative square root of 2, you put it into here, what's going to happen? And you can just write this as an equation, right? If you do negative root 2 all squared plus y squared equals to 2, what does this become? This becomes, what's negative root 2 all squared? That's just 2, yeah. So I get 2 plus y squared equals to 2, or y squared is equal to 0. So this is just going to be 0. And actually, you get a clue from that, because hang on, if this is my circle, it's a center at 0, 0, with a radius of the square root of this, so the radius is root 2. In fact, you'll get the same thing on the other side as well. Yeah. That should be root 2, sorry. So this length here will also be 0. What about when x is equal to -1 now? What's going to happen?
X equal to -1 is 1. X, y is equal to minus 1 squared.
Which is just 1. And so y squared equals to +1, or y equals to plus or minus 1 there. Okay. Yeah, 1. Okay, and it's logical that these would be the same values because this is a circle, right? And so actually the radius has to be the same all the way around. That's why we get these same values here. Let's look at the mapping now. The mapping is interesting because I kind of gave you a hint of what this is supposed to be, but now we can see it much more clearly. If I take my values, what are the x values I have? From -√2 to +√2. Yeah, 2. And what about my y values?
The bottom.
Yeah, which is actually in fact the same thing.
It's gonna be a test.
Yeah.
No, we're studying.
Well, learning is just an enjoyable pursuit in general. So now, with our one-to-one function, remember we had the same x values on one side and same y values on one side, but there was only one arrow going from one to the other. What's going to happen with this one? Well, if you take, for example, -√2, right, that only goes to one of them, it only goes to 0. Okay, that's not particularly interesting. What happens with -1 though? It goes to two values. Yeah, it goes to -1 and +1.
Oh, 1 goes to -1 and +1.
1 goes to -1 and +1.
Yeah.
And √2 goes to just 0. I might do that in the same color. Yeah, okay. So a lot of different colors going on. But the idea is this, right? How did I name these? I named them based off, hang on, what's kind of coming out and what's going in. So if I have multiple arrows coming out from something, that's what we called many. In this case, right, I think we were saying, okay, there's many arrows pointing to here, but there's also many arrows coming out from there, right? So that's why we call this many to many, right? Yeah. I was just figuring out how to explain it to you.
Basically, two of them together.
Yeah, if you mash, yeah, that's a great idea. That's a great explanation. If you mash both of these together, then you get left with what we call many to many.
Why are we learning this?
Because we want to, in the same way that we describe things, we want to have a better understanding of what types of relations that we have. We don't just want to say, oh, this is x squared plus y squared equals 2. This is just y equals x squared. We want to be able to describe the relations we have in a better way.